Hi, this is Miss Gunter. This is Unit 4, Lesson 10, Solving Quadratic Equations in Vertex Form. And this is a should-do lesson. The aim is how can I solve quadratic equations in vertex form? And the objective is I can solve a quadratic equation in vertex form algebraically. The standard form of a quadratic equation is y equals ax squared plus bx plus c, and the vertex form of a quadratic equation is y equals a times x minus h squared plus k, and in both cases a is not equal to 0. In this lesson, we're going to solve quadratic equations that can be written in the form x squared equals a, where a is a real number. The steps that we're going to take to solve quadratic equations that can be written in the form x squared equals a are as follows. We're going to isolate the variable by using inverse operations, similar to what we did when we were solving linear equations. We're going to write the equation in the form x squared equals a, and then we're going to take the square root of both sides of the equation, because the inverse of squaring a number is finding the square root of the number. Now, when finding the square root of a number, we need to remember that there are two solutions, one positive and one negative, and we use the plus or minus symbol, which is this symbol here, to show that there are two solutions. Now let's look at an example. Solve x squared equals 16. The x is squared. I need to get rid of that square. So I'm going to do the opposite of squaring, which is finding the square root. So I'm going to find the square root of both sides of this equation. So I'm going to have the square root of x squared equals the square root of 16. Now the square and the square root, because they're opposite operations, they're going to cancel each other out. So on the left-hand side, the square and the square root cross cancel, and I'm left with x equals the square root of 16. Now, when we find the square root of a number, we're basically saying what number multiplied by itself is going to give me 16. Now that could either be positive 4 times positive 4 gives me 16, or negative 4 times negative 4 also gives me positive 16. So when we find the square root of a number, we need to remember to put a plus or minus. So the square root of 16 here is either x equals plus 4, and another solution is x equals negative 4. And we can write this as x equals plus or minus 4. And these are the solutions. Let's look at another example. X minus 2 squared equals 25, and we need to solve for x. Now, the inverse of squaring is finding the square root. So the first thing we're going to do is rewrite this using the square root symbols. We're going to find the square root of both sides of this equation. So the square root of x minus 2 squared is equal to the square root of 25. Now, squaring and finding the square root are opposite operations. So on the left-hand side, the square and the square root cross-cancel each other, and then we're left with x minus 2 equals the square root of 25. When we find the square root of a number, we always have two solutions. So in this case, the square root of 25 is either positive 5 or negative 5. So we can rewrite this as x minus 2 equals plus or minus 5. I am still not done with the equation because I don't have the variable by itself. So continuing this, I can get two separate equations from this. And the two separate equations are x minus 2 equals positive 5 and x minus 2 equals negative 5. Solving the equation on the left, I'm going to add 2 to both sides of that equation, and then I'll be left with x equals 7. Solving the equation on the right, I also add 2 to both sides, and I'm left with x equals negative 5 plus 2, which is negative 3. So my solutions are x equals 7 and x equals negative 3. Example 3. Solve 4 times x minus 7 squared minus 2 equals 2. We're going to use inverse operations and first get rid of whatever is furthest away from the variable. So the minus 2 is furthest away from the variable, so I'm going to add 2 to both sides of the equation, and then I'm left with 4 times x minus 7 squared equals 4. Now I want my equation to be in the form x squared equals a, so I need to get rid of that 4 that is being multiplied by x minus 7 squared. The inverse of multiplication is division, so I'm going to divide both sides of the equation by 4. The 2 4's cross cancel, and I'm left with x minus 7 squared equals 1. To get rid of the square, I have to find the square root of both sides of the equation. So I'm going to rewrite this as the square root of x minus 7 squared equals the square root of 1. The square and the square root on the left-hand side cross cancel, so I'm left with x minus 7 equals the square root of 1. Then, of course, whenever we find the square root of a number, there are two solutions. And in this case, the square root of 1 is either positive 1 or negative 1. So I rewrite this as x minus 7 equals plus or minus 1. Now we can put the number in the calculator to find the square root of the number, but we have to remember to add the plus or minus. The calculator is just going to give us a positive square root. We need to also put the minus sign to indicate that there's a negative number as well. So the two solutions, or the two equations that I get from this are now x minus 7 equals 1 and x minus 7 equals negative 1. Then solving for x on this side, I add 7 to both sides, and I'm left with x equals 8. And over here, I also add 7 to both sides, and I'm left with x equals negative 1 plus 7, which is positive 6. So my solutions are x equals 8 and x equals 6. So in summary, when solving quadratic equations that can be written in the form x squared equals a, you isolate the variable and take the square root of both sides of the equation. And remember, whenever you find the square root of a number, you're going to have two solutions, one positive and one negative.